Hello! This week, let's take a walk through some output from your one-way ANOVA to see what we've got and see what we're looking for here. Now, a one-way ANOVA is very similar to a t-test, the big difference being that instead of comparing two groups in our independent variable, we are comparing three groups in our independent variable. So, when we look at our data, we see again that we have one variable called class in this instance, and it has three groups: online, face-to-face, and hybrid. And our dependent variable, again, is an interval or ratio variable, a statistical skills test score. So if you've been thinking this is pretty hard to take statistics in an online environment, this is the kind of study you would run to see if that's actually true. So those are our two variables. Again, we have one independent variable with three groups and one dependent variable that's at an interval or ratio level. You can tell me which one in your assignment. So we then move to our page 2 of the output. Again, we have descriptive statistics, and we have a mean, median, mode, standard deviation for our statistics test that you'll want to report to me. We see the same numbers for class type, but remember, we are not going to report those. We do not report descriptive statistics for nominal or ordinal variables because they don't have meaning. And in fact, we should not even be adding together two numbers that how do you add together online plus face-to-face and divide by 2? That doesn't really make sense. Yes, they have numbers, so we can theoretically do it, but we shouldn't, and it doesn't have any meaning, so we will not report the class type descriptive statistics. Next page, again, we have the statistics broken out by group. And then on page 4, we have the frequency tables again, which again are interesting to look at. It's interesting that there's one person who got most tests, except we see that 3 people got an 83. And I suspect when we move down here, we will see that same thing in our distribution. So you're going to want to describe the distribution for me. When we look at this distribution of skills, statistics skills test scores, we see there's definitely unimodal, there's one common score, and it's pretty normal. We've got the same amount of people kind of on the left side and the right side. So you're going to describe that as well. And then here are our ANOVA results on the last page here. So what you've got here, the kind of important point, is to look at your effect of your independent variable. Remember, our independent variable in this case is class. And again, just like with our t-test, the big thing is that level of significance greater or less than 0.05? If it is greater than 0.05, not 0.5, 0.05, if it's greater than 0.05, remember, we're saying the probability of our null being true is fairly high, and we're not going to reject that. If the probability of our null being true is less than 0.05, then we would reject it because it's probably not true in the population. So we're going to be looking at that significance level. Now when you report the results, you're going to want to report the F statistic, and you're going to want to report the degrees of freedom for class and error and the significance level. And I'll show you in the instructor guidance how to make sure you're doing that. Alright, so those are the two important things here. Now in ANOVAs, because we're comparing three things, if we have a significant result, we then run something called a post hoc test. One of the name of a common one is the Tukey, honestly significant difference, or Tukey HSD. And that would tell us, well, is the difference between the online and the face-to-face, is the difference between the online and the hybrid, or is the difference between the face-to-face and the hybrid? However, if the ANOVA is not significant, we do not run the post hoc. Now when you look at your output here, you'll see that there is a post hoc test run. So let me walk through this so you would know if it was significant what you should look at. What this table is basically each of those paired comparisons. And they do it in both directions, and the results are the same whether you do variable 1 first or variable 1 second. But again, just like all your other tests, you're looking at this significance. Now it shouldn't be surprising to you that when the overall test is not significant, that we don't see any of these pairs as significant. So what we're looking at is online different than face-to-face? No. Is online different than hybrid? No. So is face-to-face different than hybrid? No. But because if your ANOVA, again, if your ANOVA is not significant, you actually don't consider these. Ignore them, pretend they don't exist, because your overall test has already told you there aren't differences. And the key is to try to run as few tests as possible. In fact, that's the reason we run an ANOVA instead of doing 3 different t-tests, because doing one test limits the likelihood that we're going to commit that type 1 error. So that's important to think about and important to look at. Do you run that post hoc test or not? All right, so that is the one-way ANOVA. Again, fairly similar to the t-test, looking at that significance. Let me know if you have questions.